Okay, in this part, I'm going to start the routing process that will lead from the pilot operated DCV out to the actuators using my drawing as a diagram. This is why I put the T-fittings directly on the pilot operated DCV. So if you've read the description, the clamp cylinder has to extend first, followed by the drill, which means that the drill cylinder is going to have to be held back by a pressure control valve. If you follow that line where the clamp cylinder is placed, actually what we're going to look at is the drill cylinder. There's that valve right here, normally not passing, so that's going to be one of the sequence valves. So if we look at our port markings on the pilot operated DCV, we need to make a connection coming from port A to the cap ends of each cylinder, except that the clamp cylinder will actually extend first, and we will run the line through the reducer valve to it, while the drill cylinder has to be held back. So from port A we'll go to the pressure control valve, the sequence valve, and then from it we will go to the cap end of the drill cylinder. So anyway, I'll start that connection. And to reduce my amount of walking, I'm going to grab a bunch of So, let's see, we'll find port A on the DCV, which is right here. Okay, and this one right here, we're going to run over to the sequence valve. And if you're following the diagram, this hose is going to enter from port 1 and exit from port 2. All right, so here's the connection coming out of port 2, and it goes to the drill cylinder. And there's that connection. All right, now the other end of the T has to go to the clamp cylinder. So in order for it to do that, we're going to run a connection from the other part of the T-fitting over to the reducing valve. Now remember that the ports on the reducing valve are reversed, so we're going to enter port number 2. Okay, and then we're going to go out port number 1. Now, we want to make sure that we can see the adjustment on this valve. In order to accomplish that, we're going to come out of port number 1 and we're going to go to a pressure gauge. In this case, we'll go ahead and use gauge C, and what that will do is spread the hoses out just a little bit further for us. All right, and then let's see, a better connection would be around this hose, so I'll just disconnect it, and I'll do like this. Hopefully I'll have these things where you can actually follow them in the video. So out of gauge C, we're going to make a connection to the clamp cylinder. And with that gauge in that place, I will be able to see the pressure setting on the reducing valve, because according to the description, that thing has to clamp and hold at a certain amount of pressure. Okay, now we have our hoses going from one port A of the DCV to the actuators, and that pathway is now complete. So the way that works is You hit the lever and the clamp extends. When it deadheads, pressure builds, pops open that sequence valve, allows the drill cylinder to extend. Now, when the clamp is fully extended, its full extension force has to be controlled by reducing the pressure, which is done by the reducer valve downstream, which we will see on gauge C. So when we set that, we'll see that right here. All right, now I'm going to come out of port B, looking at my diagram. I'm going to come out of port B, and then I, of course, have to split off. That's why we have the T-fitting. The drill cylinder is going to come back with no hindrance. So basically what that means is I'll be able to put a hose directly on the drill cylinder and directly on gauge B, or excuse me, actuator port B. All right, now I'll get this figured out in just a second. It's a lot of work trying to get the hoses to end up where you want them to be. And blocking up these modules like I did should really help see these components, help you see the components. All right, now, so the drill's gonna come back first. There's that connection, no hindrance. I don't want that clamp to let go until the tool that drilled the part is out of the way. So we're gonna need to hold that thing back. In order to do that, I'm gonna run a connection from port B to a sequence valve. We're gonna go in port number 1, and there's the connection into port number 1. All right, and then out of port number 2, then we'll go to the clamp cylinder. So what this does for us is it ensures that that clamp cylinder does not let go of the part until the drill is out of the way and fully retracted. All right, so that pathway there basically completes the extend phase and the retract phase in sequence. We're going to have to hook up the drains next. We're also going to need to hook up our directional control valve. So basically, I'll be able to push this lever one time and the cylinders will take off. The clamp first, followed by the drill, then the drill comes back, followed by the clamp. And we'll work on that in just a minute. Okay, so what I'll do now is I'm going to tie in the check valves to the sequence valves. Remember the check valves, if you look at your diagram, they are required because the sequence valve only watches port number 1. It does not watch the secondary port. So you have to be able to get around the secondary port. All right, so we'll do this one here first. This is my reducing valve. So my reducing valve has the ports numbered in reverse. The inlet is actually number 1. Okay, and so since the ball always faces the inlet port, we'll go ahead and connect that hose right there. Then this completes the wraparound. I hook up this hose right here. To this end of the check valve. All right, that one there is complete. Now we'll do the next one. This is port number 1, going to the block side of the check. Port number 2 going to the other side. So the ball faces the inlet port that forces the oil through the relief valve in the direction that we want. Okay. Now I'm going to wrap around the last check valve, and let's see how we're going to do that. Possibly I will need slightly longer hoses. Okay, so since this flow control is closest, I'm going to go ahead and use it and make sure that the needle valve is closed. So I'm hooking up the end of the flow control, which blocks flow using the check valve. Since we're going to a sequence valve, the ball always faces the primary port, and that's this connection right here. All right, and then this is my outlet port, and it goes on the other end so that the oil can bypass the valve when it needs to, when the oil is coming back around, when it's flowing in the opposite direction. So anyway, now we have our sequence valves and our reducer valve connected. And our check valves are also in place. And I'm going to now hook up the input signal, which is this manual valve here. If you look on page 13, you see where it is on this module, you'll know which one I'm talking about. And what we're doing is we're manipulating the valve, hooking it up in a way that you don't normally see it. So it is actually a 4-3 valve, but we're going to use it as a 3-3 valve. In other words, it's a 4-way valve used as a 3-way. That means one port's not going to get used. And according to my diagram, we're not going to use port A. So port A will be left disconnected. I've already got my pressure port being used, and I have a tank port being used. So the last port connects directly to the pilot operated DCV, and that's going to be port T, which is this one right here. All right, so I'll get a hose long enough to connect that. I hope this one's long enough. All right, now this starts everything. So I got to look at my normal position on this valve right here, which is indicated by the schematic symbol on top. Anyway, it indicates that the block with the crossed arrows is the normal position. So where the arrows are straight, that is the position that causes the cylinders, is that correct? That causes the cylinders to extend. So normally you have cylinders retracted, so the oil would be under pressure when they're retracted while the machine's running. So let's think about this for a minute. I got to make sure I get that when that cam valve is struck. So, all right, let me double check and make sure I connected it this way. So that's the normal position. And then when you come out of port B, it should be going to the rod ends. And if I did not do that, well then I got to take all this back apart. All right, we'll find out real quick. All right, that one there is correct. This one here is correct, so that is the normal position. All right, so to get this thing to extend, then this has to connect to the other block. That may be hard to follow, but the block where the arrows are straight is where this connects, because that's the one that causes the extension phase of the machine cycle. All right, so the cam valve is going to hook up to the other end. That's what causes them to retract. So that's how you figure that out. So now I got to hook up a hose from the other side of the pilot operated DCV to the cam valve. You're probably wondering, I act like I'm having fun. I am. I like messing with this stuff. Makes you think. All right. Let's see if I got the right hose. All right, that's long enough. Now, here's the cam valve. Which port do we use? All right, the pressure port's being used as normal. According to this, we're going to use port A for the signal oil that causes the pilot operated DCV to shift back. So that connection right there is complete. So you got this four-way being used as a three-way, this four-way being used as a three-way. The only thing we need is for this one to have its drain connected back to tank. So the tank port of the cam valve gets connection back to the return manifold. And we are running out of connections, so we may need to use a T-fitting to make one of those connections. All right, and I'm going to pause for a second to keep the segments at a reasonable amount, at least of time and of size. And then in the next segment, we should be able to start the machine and test it in 1 minute.